Okay, so like imagine machines, right? But not just ones that just, crunch numbers or follow instruction. No, like machines that actually think like us. That's the crazy promise of artificial general intelligence, or AGI, as the cool kids call it. And lucky you, you're about to unravel this whole wild frontier.
You got it. Yeah, it's this super captivating concept that's like really intrigued scientists and philosophers for ages, but before we like totally get swept up in all the hype, we got to figure out what AGI really even is and how it's different from the AI, like the AI we see today.
Yeah, yeah, that's true. Because I mean, when we hear about AI making headlines, it's a lot about those big language models, right? Like the ones writing poems and making music and
Yeah.
stuff. I mean, that's impressive and all, but like, that is that really thinking?
So those large language models are, I mean, no doubt they're powerful tools. They can mimic human language, crazy accurate, but they're more like virtuoso parrots. Like they're good at copying patterns, but they don't really get what it all means. AGI, on the other hand, it's going for like replicating the core of human intelligence, like our adaptability, our common sense, our ability to learn and solve problems like across all these different
So it's
areas.
kind of like the difference between someone who can like recite a Shakespeare sonnet from memory versus someone who actually gets the nuances of the language, the themes, all that.
Exactly. You got it. AGI is all about making machines that not only, process information, but actually understand it, reason about it, and use that understanding for new situations.
Gotcha. So then, where did this whole audacious pursuit even start?
Well, the roots of AGI, they go way back to the mid 20th century. The Dartmouth Summer Research Project back in 1956, that was a big one. It was this gathering of all these brilliant minds just like overflowing with optimism who really believed that like creating thinking machines was just a matter of time.
Oh, they must have hit some roadblocks along the way, though, right? I mean, we're still talking
Mhm.
about AGI as this future thing all these decades later.
Oh, they did. They did. And those roadblocks, they were more like huge mountains. As researchers dug deeper, they realized that like copying human intelligence was way more complex than they thought at first. It wasn't just about faster computers or fancier algorithms. It was about understanding intelligence itself, something we still struggle with today.
Which brings us to something our sources keep pointing out, this idea of common sense being this huge hurdle for AI. Like, it seems so simple to us, but current AI systems just can't seem to crack it.
Yeah, common sense, right? It's one of those things you don't even think about until you try to like explain it to a machine.
Yeah.
It's this crazy web of knowledge and intuition and experience that helps us just navigate the world. Understand those unspoken social cues, know that like water is wet and fire is hot, all without like needing instructions.
I'm thinking about all those times we've seen AI just totally miss a joke or like make a social blunder, It's funny. But it shows how deep this whole common sense problem really goes.
Exactly. And it really shows a fundamental difference between like the AI we have now and true AGI. Right now, even the most advanced AI systems, they're basically like really fancy algorithms following pre-programmed instructions. But
Mhm.
true AGI, it might need something more, something like what our sources call organismic agency.
Okay, now we're getting to the good stuff. Organismic agency. Sounds like something straight out of sci-fi.
Well, it's a concept borrowed from biology, actually. Think about a living organism, even a simple one. It senses its environment, reacts, seeks out food, avoids danger. It's got this drive, this internal state that guides its actions.
So you're saying that true AGI, it might need like its own desires, its own goals, something like a will that makes it do things.
Yeah, exactly. That's the idea. It's a total shift from how we design AI now. And it brings up all these questions about like how would we even start to make something like that?
This is like blowing my mind. It's like we're not just talking about building a smarter calculator, but like creating something completely new, something that like mirrors life itself.
And that's just the beginning. Our sources, they dive into another fascinating concept that shows just how complex AGI is, this idea of affordances.
Affordances. Okay, now I'm really curious. Tell me more.
So think of affordances as like all the things you can do with something in the environment. Like a door handle, it affords pulling or pushing. A chair, you can sit on it. A hammer, you can hit things with it. To us it's obvious, but for an AI, it's a big challenge.
But wouldn't an AI, like especially a robot, be able to like see these affordances through its sensors and stuff?
Sure, robots can be programmed to like recognize and interact with specific things, but really understanding affordances, it goes way deeper. It's about the ability to like creatively use objects in new ways based on the situation and your goals.
Oh, I see what you mean. Our sources, they give this example of like jury rigging,
Hmm.
how we can just grab something random and figure out how to use it to solve a problem we've never seen before.
Yeah.
Like using a shoe to hammer a nail or a credit card to tighten a loose screw.
Exactly. It's about seeing beyond what something's supposed to be used for and realizing its potential for like brand new applications. That kind of creative problem solving, that ability to improvise and adapt, that's what current AI systems, they can't do that.
So even robots, like robots learning in the real world, interacting with stuff,
Yeah.
they're still limited by their programming when it comes to like really getting affordances.
Yeah, exactly. They might struggle to go beyond what they already know and come up with truly new solutions. And this limitation, this inability to use affordances, it might be one of the biggest things holding back true AGI. And it goes back to that organismic agency thing, that need for a drive to explore and discover, not just follow instructions.
Okay, so what I'm hearing is HI isn't just about making a super smart computer. It's about replicating what makes us intelligent, our creativity, our adaptability, our ability to learn and grow in like all these open-ended ways. It's about creating machines that don't just copy us, but actually understand and experience the world kind of like we do.
You got it. Spot on. And it's important to remember AGI is still a long way off. We're just starting to understand how complicated it is to create something like that.
Okay, so we talked about the challenges, but what about the potential? What could AGI do if we actually pulled it off?
The potential is, well, it's almost impossible to grasp. Imagine machines that could solve these big scientific problems, design life-saving tech, help us understand the universe in ways we can't even imagine.
It's both exciting and kind of scary, right?
Totally. And that's why we got to think about the ethical and societal stuff along with the technical challenges. If we make machines with true agency, with their own goals, how do we make sure those goals match up with ours?
Yeah, that's a question that needs a whole deep dive on its own.
You know it. It's a conversation we need to be having globally with experts from all over. We need to think about the risks, set ethical guidelines, really think about how we want to shape AI's future. But maybe we can save that for another time. For now, why don't we explore the history of AGI, see how the field has changed over the years?
Sounds good to me. Let's trace the path that got us to this incredible point in AI's evolution.
So we talked about how AGI is this ambitious thing, trying to make machines that think like us, but it's a journey that's had its ups and downs, lots of excitement and then some letdowns too.
You're talking about that AI winter, right?
Yeah.
Like I've read about how everyone was so optimistic at first and then it kind of hit them that this problem is like way harder than they thought.
Exactly, yeah. That first wave of like, we can do this, fueled by that Dartmouth conference and some early wins and things like, game playing. Well, it kind of crashed into the reality of how complex AGI really is. Funding dried up, research slowed down, and for a bit, the dream of thinking machines, it kind of faded away.
But AI research didn't totally disappear, did it? I mean, look around. We're surrounded by AI today.
Mm.
Algorithms recommending what to watch, voice assistants answering our questions, all that.
You're right. You're right. What happened is AI research kind of shifted gears, moved away from that big, huge goal of AGI and towards like more practical, doable things. Instead of trying to build one system that could do everything a human can, researchers started making specialized AI that were good at specific tasks.
It's kind of like saying, okay, so maybe we can't have a robot butler who can clean, cook, and write a bestseller, but hey, maybe we can get one that's like a pro at folding laundry.
Haha, yeah, perfect analogy. And that shift in focus, it led to some serious progress in things like expert systems, natural language processing, all that, and machine learning. These specialized AI, they were super useful, and they set the stage for the AI boom we're in now.
So how did we go from that specialized AI back to like chasing AGI again? Did those specialized systems just like get so good that they kind of merged into something more general?
It's not quite that simple, though building on those past successes definitely played a part. As these specialized AI get more and more advanced, researchers started thinking, what if we could like combine them, integrate them somehow, maybe create something bigger, better?
Okay, so now we're talking about cognitive synergy, right? This idea that like different cognitive processes working together can lead to a boost in intelligence.
You got it. That's a concept that's it's been around for a while, and it holds a lot of promise for AGI. Think about how you think, right? You might start with logic, then boom, you have a creative idea, then you draw on your memories, your emotions to make a decision. It's this flow between different ways of thinking that makes us really intelligent.
So then the key to AGI might be like figuring out how to copy this synergy, this back and forth between different AI systems. So not just a bunch of specialized AI working solo, but making them talk, collaborate, use each other's strengths.
Yeah, exactly. It's a huge challenge, but researchers are like attacking it from all sides. One promising way is to develop better, more flexible learning algorithms, kind of inspired by how the human brain learns and
So
adapts.
that's where deep learning comes in, right? I've heard so much about it, how it's changing AI, but to be honest, I'm still a little fuzzy on how it actually works.
Deep learning, oh, it's a fascinating field, and for sure a big player in the AGI game. At its core, it's about training these artificial neural networks on mountains of data. These networks are like modeled after the human brain with these interconnected layers of artificial neurons that process information and learn to spot patterns.
So instead of like programming an AI with rules and instructions, we feed it tons of data and let it figure out its own rules.
Yeah, that's basically it. It's like teaching a kid about animals by showing them tons of pictures instead of giving them like a whole anatomy lesson. Through all those pictures, the kid's brain learns to see the differences, the features of each animal. Deep learning tries to do the same thing, but with machines.
Okay, that makes sense. But how does this get us to AGI? I mean, seeing patterns in pictures or text, that's cool, but it doesn't seem like the general problem solving we see in humans.
You're right. Deep learning alone isn't going to get us to AGI, but it's a powerful tool, and we can combine it with other techniques to make more versatile AI. One promising way is reinforcement learning, which we talked about before.
Right, the digital dog training thing. You reward the AI for making good choices, but I'm
Mm.
still not clear on how that gets us to general intelligence.
Okay, imagine you've got this AI and you want to teach it a tough strategy game like Go. Instead of, programming and all the rules and strategies, you just let it play thousands of games against itself. Reward it when it wins, penalize it when it loses. Over time, through all that playing, the AI starts developing its own strategies, learns from its mistakes.
So it's learning by doing, kind of like a kid learning to ride a bike or play an instrument. But instead of the real world, it's learning in this virtual world like a game.
Exactly. And the cool thing is, we can use this approach for all sorts of problems, not just games. You could create like a simulated city, have the AI learn to navigate or solve engineering problems, or even like interact with other AIs in a social setting.
That sounds amazing. But are there like any limits to this approach? Can we really expect an AI to get true general intelligence just from, playing games or messing around in a simulation?
That's a great question, and it gets to the heart of some of the big debates about AGI. One challenge is making sure that simulation is complex and diverse enough to actually foster general intelligence. If the AI only sees a limited set of scenarios, it might learn some skills, but then struggle when faced with something new.
So it's like the difference between learning chess and being a grandmaster. You can learn the basics playing against a computer, but to really get good, you got to play against humans, people who can surprise you, throw you off your game.
Yeah, exactly that. And that's why researchers are looking into ways to create more open-ended, dynamic learning environments for these AIs. One idea is to use procedurally generated content where the environment itself is always changing, throwing new challenges at the AI, giving it more opportunities to learn.
That sounds a lot like the real world. We're always running into new situations, having to adapt our thinking. It seems like we're getting closer to AI that can learn and grow kind of like humans do.
There's definitely a lot of exciting work happening in that area, but reinforcement learning isn't the only approach out there. Another really cool one is evolutionary algorithms. They take inspiration from natural selection.
Oh, so now we're talking about survival of the fittest, but for AI. I've heard of this, but how does it actually work?
It's a pretty cool concept, and it's had some impressive results. Imagine you start with a bunch of AIs, each with different traits and abilities, represented by like digital genes. They compete in a simulated environment, and the ones that do well, they're more likely to like survive and reproduce, passing on their digital genes to their offspring.
So it's like digital Darwinism. The best AIs get to pass on their traits. But how does that create general intelligence?
The idea is over many, many generations, this process of selection and reproduction will eventually produce AIs that are really good at solving lots of different problems. The AIs that develop helpful traits like better learning or problem solving, they have an edge and are more likely to pass those traits down.
So it's like this massive parallel search for the perfect AI design, where each generation builds on what worked or didn't work for the ones before it. Kind of like watching intelligence evolve right in front of us.
That's a great way to put it. And the cool thing about evolutionary algorithms is they can explore tons of possible solutions without like needing a human to guide them. It's like letting nature do its thing, but instead of, biological organisms, we're evolving digital minds.
This is all super promising, but I can't help but wonder if we're still missing something important. We've talked about deep learning, reinforcement learning, evolutionary algorithms. But what about that organismic agency thing we discussed before? Can these approaches really make AIs that have their own goals, their own motivations, not just following instructions or chasing rewards in a simulation?
That's that's a deep question, and it's a big one in the AGI world. Some researchers think that agency might just like emerge naturally as AI systems get more and more complex.
So it's not something we program in, but something that just kind of happens, like consciousness coming from all the neurons in our brain.
Yeah, exactly. It's a mind-blowing idea, one that's fascinated philosophers and scientists forever. Others think we might have to totally rethink how we design AI if we want true agency.
What would that even look like? Are we talking about like a complete revolution in how we think about AI?
It's definitely possible. Some researchers are exploring totally different computational models inspired by like biological systems or even quantum mechanics. They're trying to create AIs that are more than just, fancy algorithms. They're looking for ways to give AI a sense of self, a purpose, a drive to explore and understand the world on its own terms.
This is like we're going way beyond the map here. It's sci-fi stuff. But maybe that's what it takes to really understand and unlock the power of AGI.
The quest for AGI is pushing us to face these huge questions about intelligence, consciousness, even like the nature of reality. It's a journey, exciting and scary, full of both promise and potential danger.
This has been an incredible exploration so far. We've gone through the history of AGI, all the complexities of deep learning and reinforcement learning, even touched on those mind-blowing evolutionary algorithms. But I feel like we're just getting started.
Oh, you're absolutely right. We've only just begun to unpack all the different approaches researchers are trying out to make truly intelligent machines. And as we go deeper, we'll find even more cool concepts, groundbreaking discoveries, and things to really think about.
I can't wait to see what's next. Lead the way. I'm ready to dive in deeper. So we've covered a lot of ground, right? The history of AGI, the challenges, the possibilities. We even got into deep learning, reinforcement learning, all those evolutionary algorithms. But it still feels like there's so much more to discover. So many questions about, you know, truly intelligent machines.
You're right about that. The field of AGI, it's like the huge unexplored wilderness. Researchers are always pushing the limits, finding new paths, challenging what we thought we knew.
It's both exciting and kind of scary, right? Like we're on the edge of something totally new, something that could change everything.
For sure. AGI could reshape our world, for good or for bad. And as we go deeper into this unknown, we got to be careful, but also, stay curious. We always have to think about what this all means, ethically, what the consequences might be.
That's a good point, a really important one. It's easy to get caught up in the excitement of new tech, but we can't forget about the human side of things, our values, the things that should guide us as we explore and create.
Absolutely. AGI isn't just science, it's a human endeavor, and it needs our full attention, our critical thinking, all of our wisdom.
So as we navigate all of this, what are the big questions we should be asking? What do we need to think about as we try to create, truly intelligent machines?
Well, I think one of the most important questions is how do we even define intelligence? What does it really mean for a machine to be intelligent? Is it just about, processing information quickly? Or is there something more, something we can't quite put our finger on that makes human intelligence unique?
That's a big one, a real philosophical question. I mean, if we can't even agree on what intelligence is, how can we create it in a machine?
You got it. And even if we can define it perfectly, there's still the question of can we even copy it? Is the human mind just like a complex algorithm, or is there something else going on, something that comes from the way our brains are wired?
You mentioned earlier that some researchers believe agency, that drive to act, might just appear on its own as AI
Yeah.
systems get more complex. Is that something we need to take seriously?
It's a really interesting idea and one that's causing a lot of discussion in the AI world. Some people think that if we can make AI systems that are, really complex and interconnected, they might develop a sense of self, a sense of purpose, even like a basic form of consciousness.
That's both amazing and a little creepy, right? I mean, it brings up
Oh.
questions about control, responsibility, what it means to be human.
For sure. If we create machines that are truly independent, machines that can think for themselves and make their own choices, how do we make sure they act in ways that, align with our values, with what we want? How do we make sure they don't become a danger to us?
Those are big questions, and we need answers sooner rather than later. It feels like the ethics of all this are just as important as the technology itself.
I couldn't agree more. As we push AI further, we need strong ethical frameworks, guidelines to make sure these technologies are used responsibly for the good of everyone.
So it's not just about making smart machines. It's about making smart machines that are also, you know, ethical, compassionate, machines that get human values and work with us to build a better future.
Exactly. And that's why it's so important to have everyone at the table for these conversations. Not just engineers and scientists, but also philosophers, ethicists, social scientists, policymakers.
It feels like you're calling us to action, to really think carefully about how we develop AI.
It is a call to action. The future of AGI, it's not set in stone. We're shaping it with every choice we make, every line of code we write, every ethical principle we follow.
So it's not just about the tech, it's about how we use it, our values, our goals, what kind of future we want.
You got it. And that's why we need to have these conversations, grapple with these tough questions, and try to build a future where AI helps humanity, not the other way around.
This has been, wow, this has been an incredible journey. We've gone deep into this world that's both like awe-inspiring and really challenging. I feel like I have a whole new understanding of AGI, what it could be, and the responsibility we have as we create it.
It's been great exploring all this with you. And to you, our listener, we hope this has made you curious and that you keep thinking about these big questions, these questions about technology, intelligence, and what it means to be human.
Yeah, keep exploring.